This educational video, brought to you by LabRoots, will focus on exoplanets and the suggestion of, are we unique in the universe? Is there life elsewhere in our galaxy or in the universe? LabRoots is the leading professional networking website designed to connect the scientific world, leveraging a myriad of unique features, helping users discover meaningful collaborations across geographic boundaries and fields of expertise. Providing educational tools such as webcasts are part of LabRoots' ongoing effort to help science and technology professionals better communicate and disseminate information among each other, effectively educating users on the latest discoveries and innovations in their area of expertise. For hundreds of years, scientists have believed that planets existed outside of our solar system. But until recently, we did not have the technology to discover them or know if they were similar to planets within our own solar system. Scientists have discovered planets outside of our solar system. They are called exoplanets or extrasolar planets. The first exoplanet was discovered in 1995. This was a giant planet orbiting around a nearby star called 51 Pegasi. Since then, the technology for discovering exoplanets has vastly improved and allowed us to discover thousands of them. There are several techniques being used to discover these exoplanets. Radial velocity. Certain stars are affected by the gravity of the planets that orbit them and will wobble from this effect. Through Doppler spectroscopy, scientists can detect this wobble. It is easier to spot this effect with low-mass stars and the gravitational tug that planets put on them. Transit method. This method detects planets when they cross or transit in front of the star, and the amount of light changes as seen from the star. There is a high rate of false positives using this method, and it needs to be confirmed using radial velocity or some other method. However, it is easier to gauge the size of the planet and the atmosphere around it using the transit method. Timing variations. A planet that is orbiting a star can create variations of timing for orbiting periods of other planets that orbit the same star. This can confirm the presence of one or more planets, but doesn't give us much other information about them. Gravitational lensing. This technique is used if there is a star in front of another star, and the gravitational field of the star in front creates a lens and magnifies the light from the star behind it and any planets orbiting that star. This method is useful for finding planets around stars in the center of our galaxy, where there are a multitude of background stars to create the lensing effect. Direct imaging. This is a very difficult way to discover exoplanets. Planets reflect light from the star that they orbit. When they are close to the star, they are lost in the glare. When they are far away from the star, they do not reflect much light. If the planet is very large, larger than Jupiter, it can give off a significant infrared signature that makes it more visible. Astronomers can use a coronagraph to block out the light from the star and make it more visible as well. The Kepler Mission was designed by the United States and NASA to look at a very small portion of our part of the Milky Way galaxy, to find exoplanets and specifically to find Earth-sized exoplanets that orbit the habitable region of the parent star, and then to extrapolate that information to determine how many billions of stars in our Milky Way galaxy have these potentially habitable Earth-sized planets. As of January 1st, 2014, the Kepler mission has found 3,568 candidate planets. 1,055 are confirmed and reside in 801 planetary systems. Most of the planets discovered are Jupiter size or larger and consist mostly of gas. A small percentage, 1+%, are Earth-size and are rocky in consistence. There is a larger percentage that are also rocky, but much larger than Earth and referred to as super-Earths. The vast majority of these planet discoveries used the radial velocity method. Through the discovery of exoplanets, the interest in finding habitable planets with the possibility of some form of life has increased significantly. The interest lies in finding planets orbiting in the habitable or Goldilocks zone of the parent star, not too hot, which is too close to the star, and not too cold, which is too far away from the star. The habitable zone, where there could be an atmosphere and liquid water on the surface, and therefore the possibility for some form of life to exist. Based on the Kepler project and other related studies, scientists estimate that there are as many as 40 billion Earth-sized planets in our Milky Way galaxy. The likelihood or probability that some form of life exists within our galaxy is huge. Astronomers estimate that there are hundreds of billions of galaxies in the universe, and that most of them are common to our Milky Way. Is there life out there? What do you think?